Okay, if not, I will explain. So this value of A at s equal to 0 is 6 upon 1. That means value of A is 6. Value of A is 6. In the same manner, if you evaluate B, value of B is 4 plus 6 divided by s, and value of this function at s equal to minus 1. Then this will come as a minus 4 plus 6 divided by minus 1. That is, what is B? What is B?
-2.
Minus 2, I think, right now. Minus 2, yes. Therefore, L inverse of 4s plus 6 divided by s into s plus 1 can be written as L inverse of A is 6, 6 upon s plus B is minus 2 upon s plus 1. So this can be written as, what is 1 upon s inverse Laplace?
1.
Minus 2 into e to the power minus t. So that value I will substitute. Therefore, to the left side, this y of t is given by, t can be taken outside. So inverse Laplace of 1 upon s raised to 4. Quickly. T cube divided by 3 factorial, I think, right now? This is t cube divided by 3 factorial plus second term is 6 minus 2 into e raised to minus t. That is, y of t is given by t cube divided by 3 plus 6 minus 2 into e to the power minus t. This is the final answer. Just check. Third example. Solve y double dash t, that is a d2y by dt square, plus y of t is equal to t, and it is given that the initial condition y dash of 0 is equal to 1 and y of pi is given as a 0 by using Laplace transform. Okay. Suppose solution for this. What is the given equation? I will scroll up. So given that y double dash of t plus y of t equal to t, and also it is given, suppose if required, I will write this as a 1. Also it is given that y dash of 0 is 1 and y of pi equal to 0. So taking Laplace transform on both sides. Taking Laplace transform on both sides. Yes, Sakshi, can you tell what will come the left side? Directly I will write the step. Now 2 examples are written. So Laplace transform of d2y by dt square. Suppose highlighted term. Sakshi is there? No. Namrata?
L of y double dash t plus
Answer पाहिजे मला s square मध्ये. So it can be written as s square y bar of s minus s y of 0 minus y dash at 0. Is it right? Next, the Laplace transform of y of t is directly y of s. And what is Laplace transform of 1 upon t right side? 1 upon s square. Now, if you substitute, I don't know, I know y dash 0 only. Y of 0 is not given to you. This is not given. So that's why I will assume. So let, it is a constant, still you have to identify. Y of 0 is equal to 1. Then this expression can be written as y square, sorry, s square. Just a minute. So this can be written as s square into y bar of s minus a into s, because I am assuming that y of 0 is a constant and y dash 0 is 1. Now after this, plus y bar of s is equal to 1 by s square. Now again, I will collect the terms of y bar together, that I will highlight here. This term and this term. Suppose if you are taking these two terms together, so this can be written as s square plus 1 into y bar of s equal to 1 upon s square plus as, sorry, as, not x, this is s, as plus 1. Okay, our aim is to find y bar and after that apply inverse Laplace transform. So this can be written as 1 upon, see, first term s square into s square plus 1. Is it okay? Plus second term a into s upon s square plus 1 plus 1 upon s square plus 1. Am I right? Simply I am taking y bar. So taking inverse Laplace transform, taking inverse Laplace transform, inverse Laplace transform, then you will get. So when you take inverse Laplace transform, left side we get original function y of t. Now here I will write L inverse of 1 upon s square into s square plus 1 plus a into L inverse of s upon s square plus 1 plus L inverse of 1 upon s square plus 1. Suppose this equation maybe I will call as number 3. Now, here you can notice directly this is in the standard form. This is also in the standard form. Only we have to evaluate inverse Laplace transform for the highlighted term. So for that, you may use convolution theorem. You may use what we can say partial fraction. Any method you can use. Tell me which method I should follow. Accordingly, I will go. At least tell me the name. To find the inverse Laplace of highlighted term, I have to go with the convolution or partial fraction. बोला रे. Hello. Convolution we should go or partial fraction. Both we have to calculate. Some method may become easy one, some may become complicated. Convolution, Rishabh, Vardhaman, Namrata, Pranoti, any one of you tell me either partial fraction or convolution. Okay, partial fraction. Someone says convolution, someone says partial fraction. By both method you can continue. I will continue with the partial fraction suppose, or convolution, partial fraction suppose. Consider 1 upon s square into s square plus 1 can be written as a naught upon s square plus a1 upon s plus, what is the next term? bs plus c divided by s plus 1. Okay. Now here I will calculate a naught. A naught is given by 1 upon 0 factorial 0th derivative of 1 upon s square plus 1 and value of this function at s equal to 0. This implies this a naught is equal to 1, I think. Check. Next, a1 is given by 1 upon 1 factorial first order derivative. Yes, I'm corrected, na? First order derivative of 1 upon s square plus 1 and value of this function at s equal to 0. This is 1 upon 1 factorial, that becomes 0, and derivative of this by using first 1 upon s minus 1 upon this term and multiplied by derivative of s square plus 1 and value of this at s equal to 0. So obviously this becomes a1 becomes 0. Okay, a1 becomes 0, a naught is 1. Now for the remaining, I will take the cross multiplication. Now to the left side of the write up, 1 is equal to a naught multiplied by s square plus 1 plus a1 multiplied by s into s square plus 1 plus bs plus c multiplied by s square. So one thing you can notice, a1 is 0, that's why I will neglect this term, because 0 multiplied by anything is 0. So this one I will write a naught into s square plus 1 plus b into s cube. Am I right? b into s cube plus c into s square. So equating the coefficients, or one more step, suppose if I simplify, this can be written as b into s cube plus a naught plus c into s square plus I'm missing something, plus a naught is 1. So why I'm writing this as a 1? A naught is 1. So 1 is equal to 1. Obviously you are getting equating the coefficients. Equating the coefficients. Then you will get b is equal to 0 and a naught plus c is equal to 0. That means c is equal to minus a naught, and that I will write as a minus 1. Therefore, L inverse of 1 upon s square into s square plus 1, its inverse Laplace transform is given by a naught is 1. L inverse of 1 upon s square plus minus 1 upon s square plus 1, its bracket square. Is it right? So L inverse of 1 upon s square is t minus second term is sin t. Now everything I will substitute in equation number 3. I will scroll little bit up. Yeah, this much is fine. Therefore, from equation 3, the solution is given by, from 3, this y of t is given as, first Laplace transform you are finding t minus sin t. okay, plus a into sine t plus, one should rectify my mistakes, if I may. I made some mistakes here. For this I am writing sine. Is it okay? Is it okay?
Cos.
It is cos. Okay, it is cos. It is cos of t plus sine t. But still we have to find the constant a. But you are given one additional condition. But y of pi is equal to what it is given? 0. If you look at the first one, y of pi is given as a 0, that I am highlighting. So if you apply this condition to the given, means you have to put t is equal to pi in the above equation, then it become y of pi is equal to 0 pi minus sine pi plus a cos pi. I think this term get cancelled, not necessary to write this one and this one. So that's why if you're writing, then it's okay, plus sine pi. So this term further you can write as a t minus a cos t. That means here it is not necessary to mention that sine terms. Here I will write minus a cos of pi. That means a cos of pi is equal to minus pi or plus pi. So my cos of 180 degrees is minus a, so a is equal to pi. That means a is equal to minus pi. That answer you are getting here. A is equal to minus pi. Verify that. Or plus pi. One should verify it's minus, na? Therefore, thus the final solution. Thus, the final solution is given by y of t is equal to t minus and minus, if you are substituting this value, pi cos of t. Cos of t. Up to this, any doubt? Solve by using Laplace transform. What is the equation? d2y by dt square plus y is equal to 6 cos of 2t with the condition that y is equal to 3 and dy by dt is equal to 1 when t is equal to 0. Now again, these conditions you may write as y of 0 is equal to 3, y dash of 0 is equal to 1. Okay. Now start with the given. I think no response from the student. So given that d2y by dt square plus y is equal to 6 into cos of 2t. Apply Laplace transform. I will not write all the steps. If you apply the Laplace transform, it will come as, I will give 5 minutes. I will give 5 minutes and here I will write some examples for homework, HW. So just copy the steps and try to solve from your end. So here I will write HW. And this is the end for the unit. Fifth example, solve the following differential equation. The question is solve by using Laplace transform. Fifth example, dy by dt plus 2y integral 0 to t y of t dt is equal to sin t with the condition that y of 0 is equal to 1. Sixth, d cube minus 2d square plus 5d operated on y equal to 0 with y of 0 is equal to 0, y dash 0 is equal to 0, y double dash 0 is equal to 1. Okay. After that, suppose seventh, solve the differential equation y double dash t plus 25 y of t is equal to 10 cos of 5t with the condition that y of 0 is equal to 2 and y dash 0 is equal to 0. Suppose next one, here I will write eighth d2y by dt square equal to minus 8t into e raised to minus t with the condition y of 0, y dash of 0 equal to 0. Ninth, suppose dy by dt equal to t cube into e to the power minus 5t with the condition y of 0 is equal to 0. Tenth, d2y by dt square plus y is equal to sine of t with